Hey there, After Effects folks. My name's Felt Tips, and I'm here with a tutorial for you about After Effects expressions. What should we call this? Kind of an introduction to random numbers in After Effects expressions. So, without further ado, I'm going to launch straight in. I know that when I listen to a tutorial or watch a tutorial, I do like to get it through pretty quickly, and I can always come back and rewind and replay if there's any parts I don't understand. So I'm going to rattle through it, and hopefully we'll be done in 20 minutes, if not less. Well, we'll see. Okay, new composition, 1024 by 576 PAL. And I'm going to make a new solid, 150 by 150. Double click the circle thing, the circle mask, to make it a circular thing, and we'll call it blue. Now, it doesn't matter what size you make your layer, it doesn't matter what size or frame rate you make your comp. This is purely for demonstration purposes. Now, first up, I'm going to be affecting the scale property of the layer with the expression. So I'm going to Alt and click on the stopwatch, and that gives me my first expression here. I'm going to come up to random numbers, and I'm going to choose random. Okay, what happens if I hit enter now? Oh! I knew it would happen. It always happens to me. An After Effects warning because the script, the expression, hasn't compiled. This is why expression result must be of dimension 2, not 1. Well, what that means is that scale has 2 dimensions. It has 2 individual parts. And what I've returned here is a single number. What I need to do is put the random number generated by random into a variable, which I'm going to call x, or I could call it f, or blah, 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 it doesn't really matter, any old name. And then I'm going to make an array with a length of 2, values separated by commas, and those 2 values are going to be x and x. And that is in the correct format that the scale property is expecting. Okay, so what do we got? Well, a very, very small layer. Let's just quickly click on the graph toggle and on the graph preview here. Let's look at the graph window, and let's just zoom in using the Z magnify tool to see what we've got. We've got a lot of values between 0 and 1. Well, that's good because that's exactly what you expect random to do. You expect it to generate random values, a different one on every frame between 0 and 1. Not much good for scale though. So what we need to do is multiply it by 100. And once we do that, well, zoom out a little, you can see we've got random numbers between 0 and 100. Another way to do it, of course, is instead of multiplying, is just put the 100 inside the brackets. And if you do that, exactly the same result, random numbers between 0 and 100. And you can see that that's the kind of effect that you get by using a random number method. Okay, cool, that's all well and good. Now there's another thing you can do with randoms. You can put an array in, and in the case of scale, it's an array of 2 that it's expecting to be returned, so you can say 100, 100. But this will have the effect of generating 2 separate random numbers. And here you can see that we now have 2 different lines, a red one and a green one in the graph, and you can see what's happening to our circle. The 2 scales are generating independent values. So let's stick with it as it was, just for the moment. And let's have a think about what else we could do. Now there is another type of random called Gaussian Random, or Gauss Random, also to be found under the random number methods. It works almost identically to the standard random. The only difference is that only 90% of the values fall between 0 and 100. 10% of the values fall outside. And the distribution, rather than being kind of even, is biased towards the middle. It's what's called the Gaussian distribution. So it gives a slightly sort of more organic kind of feeling. You don't really notice it in a sort of time-based animation like this. But if you were arranging things in space, for instance, you'd almost certainly notice the difference. In fact, let's do that quickly. Let's go for a new composition, 1024 by 576. Let's make a new solid, and this time let's just make it 6 by 6. And on the position value, let's alt-click the stopwatch, and let's say Gaussian Random this comp with a capital. Expression language is fussy. This comp dot height, and what that is going to do is to generate two random numbers. The first of which is between 0 and the composition's width, and the second which is between 0 and the composition's height. Well, it would do if we were just using a normal random. Let's do that. Okay, and you can see it's landed there. Let's duplicate the layer, and it's landed there. A few more, they're all landing inside. Hey, let's go wild. Okay, well you can see we've got a pretty random distribution of those layers. Very handy. Now if we come back here and we say Gaussian Random, Gauss Random with a capital R, now we're going to get a slightly different distribution. Let's just duplicate up a few of these layers. Well, as you can see already, we've got a few of them that are actually landing outside the screen's dimension. About 10% of them, in fact, are going to be outside, and that's a Gaussian distribution. Now what might be interesting is if we were to create two numbers. Let's call x, a variable called x, can be Gauss Random this comp dot width, and y can be normal random this comp dot height. Let's not forget our semicolons because sometimes it needs them. And hey, let's not forget the last line of the script or the expression either. There you go. Let's try the same thing again. Let's make 10 of those and select all of those and make another 10 of those. And hey, let's see just how many layers we can handle. Ouch, that's taxing the processor. Well, there you have it. You can see the kind of distribution that the Gaussian gives you going across the screen like that. They tend to be clumped in the middle, whereas the distribution from top to bottom is very nice and even. So there you go. That is a sort of visual demonstration, if you like, of a Gaussian random. Let's delete all those layers and go back to where we started. Now for temporal things, as I said, neither of those is particularly clever. So let's look at another random. The other one is called noise. Noise, and then we put a number, an argument in the brackets. But this doesn't work quite the same. The value that you put in the brackets, or the argument as it's known in sort of programming terms, dictates the speed of the noise and not the size of the noise. The noise that gets generated always runs between -1 and +1, whatever number you put in the brackets. Let's put time in the brackets so that that number is constantly changing. And let's not forget our semicolon at the end of the line. Same thing again, I always do the same thing. Forget the last line of the script. There you go. Now if we come in and we zoom in, let's just turn that one off and zoom right in. There you can see we've got values between -1 and +1. And we've got this sort of wobbly kind of line, this wiggly line. Now if I change to time times 2, you can see the wiggles get close together. If I change to time times 4, the wiggles get even closer together still. Time times 40, and we'll see something crazy. There you go. Now, noise is kind of good in that it doesn't give a different value every single frame. Let's just come over. Let's actually choose time times 5. And let's multiply the value by 50. Let's set the original scale to 50. That is the value before it's affected by the script. And let's pick up that value by using the keyword value. That will pick up the original value of 50 by 50. And let's add the noise to it. Now the noise that we've got there, seeing as we've multiplied -1 to +1 by 50, we're now getting -50 to +50. And if we add x, x to the original value, we'll be getting a value between 0 and 100. Let's see how that looks. Well, already you can see that there's a little bit more sort of structure to that noise. It's sort of pulsing up and down. If we turn time to 3, then you can see it's a bit more kind of organic. And there you go, you can see the noise. Now, noise to me is kind of better, more useful, certainly when you're talking about temporal animations, ones that run through time, than either of the other random methods are. But there's something, or there's a couple of things, in fact, that I don't really like about noise. And first of all, it's got these kind of flat patches where nothing happens. And secondly, that these peaks and troughs, as you can probably notice, are rather evenly distributed. And sometimes when you type in a value instead of using time, you find that kind of curiously enough, your noise comes out at sort of unexpected values or unexpectedly rounded values. If you use rounded numbers in those brackets, if you use kind of more offbeat numbers, then you get kind of nice ones. But there's something very not random about noise. So what are we going to use instead? If we want something that works in a similar way to noise over time with sort of smoother movements, but we don't want to use noise itself, what are we going to use? Well, for that one, we don't look under the random numbers menu, but we look under the property menu. And we're going to be looking at good old wiggle. Now, wiggle is a little bit different. It is definitely a random number method, but it tends to be something that you just use exactly in that form on scale. And what it does, it sort of wiggles the scale around its original value. Let's just... okay, I've got to... Yeah, type in a frequency and an amplitude. So let's type in amplitude of 50, frequency of 2, and there you go. You can see that scale is being scaled between 0 and 100 independently on each of its axes. Well, that's not entirely the effect that we were after. So how are we going to use wiggle to do the same thing as we were doing with noise, only using the nicer kind of wiggle? Because as you can see on the graph here, there is a much more sort of random wiggle, and there's good things that you can do with that afterwards, which I'll show you. What we're going to do is we're going to separate the wiggle from the original value, because if you imagine the generated value of wiggle is a scale plus the wiggled value. So if we want to get the wiggle on its own without the original scale, all we've got to do is subtract the original value before the expression using the value keyword from that value. And now you can see that wiggle is going between minus 50 and plus 50, exactly as you would expect. Okay, because the amplitude is 50. That's cool. Let's put that into a variable, the variable x, and now let's take x0 like that, and another x0 in a list or array and return that value. And now you'll see that we've got two values oscillating very nicely between minus 50 and plus 50 using this nice sort of wiggle noise here. Now then, if we take that value there, we'll call that one y, we'll put the value generated into the variable y, and as a final step we will just say value plus y. That takes the original value of wiggle and adds the new y value to it, and there we will be seeing a wiggled value lying between 0 and 100. Lovely, and you don't get any of those flat bits. You get a nice kind of random noise type of curve. And what's more with wiggle, you can turn the octaves up and the multiplier to 0.65. It doesn't really matter what value. And then it starts to superimpose levels of noise on top of one another in a kind of fractal way. If we turn the octaves up to 3, then you'll see that the noise curve starts to become more and more detailed. And if we turn it up to, say, 8, it doesn't matter how far we zoom in, we're getting this kind of fractal effect. We can go in closer and closer and closer, and wherever we look, there's noise. The more of those you do, the longer it takes to generate, but you've got that. And what's more, you can change the frequency here, turning this value up, as you can see. And in fact, what I'm going to do is I'm going to make a point expression control, and I'm going to call it frequency amplitude. And I'm just going to load those values into my expression. T freq equals the first of those, and T amp equals the second of those. And now what I can do is take that value as the frequency and drop it in, and take that value as the amplitude and drop it in. Well and good. Frequency 3, amplitude 50. Let's come and have a little look at the graph, and now I can slide the frequency up and I can slide the frequency down. As you can see, I've got full control over what's going on with this function without once having to enter the expression itself. That is what we like to see. So there you go, a little bit too erratic. I'm going to turn the octaves down to 2. You could even make a slider for the octaves if you want to. Frequency also down to 2. And let's see what we have there. Nah, that's pretty good. I think if we turn motion blur on for both of those, then we'll be looking at something reasonably smooth. Oh yes. Well, that means we're on the home straight. That means we are into the final thrilling climax of this tutorial. And for that reason, I'm going to turn off the layer blue, and I'm going to turn on the layer, or I'm going to create a layer, text, and I'm going to call it Earth. No, Earth Quake. Earthquake. Who on earth taught this guy to type? Amazing. Okay, so let's scale that down a touch. Let's just move it up a bit, and let's make it into a 3D layer. Now I'm going to use a very similar function to that which I used on scale. I'm going to use it on the position property here. I'm going to say x is equal to property wiggle, like that. Yeah, that's one thing to learn. Scripts never compile when you're working on them. I'm going to copy some of this from here. I'm going to put those 2 layers in there, and again it won't compile. Okay, and I'm going to copy the effect up onto this layer as well. Once again, I double click T frequency and replace the word frequency, and T amp and replace the word amp, and now it should compile, and indeed it does. So there you go, you can see that we have some noise, some earthquakey sort of vibration going on. Let's have a look at that. Not that earthquakey. Let's come into our frequency here, and let's turn the frequency up to 10. That's a little bit better. You know what? I'm going to put the octaves up to 2. Now that's a kind of cool movement. I like that. Good. So the other thing that I've got going on is that that's happening in all 3 channels, the X, the Y, and the Z over here, and I don't really want that. So I'm just going to come over here. I'm going to set X to be equal to an array of 3, and the first value is going to be X0. The second value is going to be X1. If I was to type the third values to be X2, then X would be exactly as it was before, as you can see. But now that I've separated that out, I can change the last value to 0, and you can see that I have the noise in the first 2 parts, but not in the Z value or the Z value. Okay, that's cool. And as a final stage, I'm going to make a slider control, and the slider control is going to be called envelope. Okay, and I'm going to bring the envelope variable into this expression. T envelope, or whatever I want to call that, is equal to the value of that effect. And what I'm going to do is I'm going to separate the wiggle part from the original value once again. So I'm just going to type in x is equal to the wiggle minus the original value, exactly like we did before. Okay, so the core position has jumped up to 0, 0, and the movement is just the wiggle. Okay, so x is just the wiggle on its own now. And what I'm going to do is I'm going to multiply the wiggle, x equals x, multiplied by t envelope and divided by 100, so that t envelope becomes like a percentage of how much of the original wiggle we want. And then finally, I'm going to add that value, that x, that wiggle, enveloped wiggle, back to the original value. Value plus x. Now, as you can see, if I turn the expression on and off, at the moment the wiggled value and the calculated value, the wiggled value and the original value, calculated value and the original value are identical. But if I turn the envelope slider up, you can see that they start to change. So when the envelope slider is up, it wobbles around a lot. When the envelope slider is at 0, it doesn't wobble at all. You're beginning to get the idea. If I now put a keyframe on envelope here at 0, another keyframe here which I turn up to 137 or so, and then another one here at 0, let's just have a quick look at that. Now then, here's a good thing. Here's a good thing to show you. Why have I got that other graph on there? I'm supposed to be looking at envelope. Well, if I just quickly roll over the graph, you can see, well, here is the earthquake slider that I'm expecting to see, this one here. This down here, that seems to be coming from a different layer. And indeed it is. If I press U on my keyboard, you can see that I've left the little graph tab on. How annoying. Always do it. And you'll always do it as well if you work a lot with expressions. So when you're looking at a graph and there's an extra line on there, just go and find where it is. It's definitely something you've just left turned on by accident. Okay, so there is my slider value. Let's just turn that off and let's come up here and we'll choose F9 just to make an eased curve in and out. And as you can see, that the line there now becomes an envelope for the movement. In fact, if we come over to position and we turn the graph on for position, you can see quite clearly that those values are now being enveloped by the envelope. Okay, well, now on to the last little part, and that is simply to add a little bit of customized animation to the whole thing. The wiggle's about there. Yep. Well, let's put a position keyframe there, and let's drag this way back at the start. There you go. Let's put a bit of a motion blur on the layer as well. Fade it in as it comes up, and there we go. A little animation. Not going to win any awards as a piece of animation, but like I said, I don't want to waste your time making lovely aesthetic pieces of animation. You want to know about expressions, you can add your own aesthetics to it. So hopefully that's taken you through the sort of ground principles of ways in which that you can use the random functions in After Effects. There's loads more to those random functions, there's loads more to know, and I'll probably continue with some more tutorials about those random functions and some more in-depth things that you can do with them later on. Okay, well, thanks for listening. Stay tuned to this space, and my name's Felt Tips. I'll see you later.